okay, I'm ready to load up the parameters. Let's just get a kind of a comprehensive range that could work for sort of any data set. So let's start with max depth. And, you know, I think 1, certainly 2, 3, 4, 5, 6, 8, 10. I usually do something like that for max depth. Because, why? Because when you're doing gradient boosting, turning a weak learner into a strong learner, emphasis should be placed on the smaller depths. Okay, but sometimes larger can be better. Okay, now I'm going to hold off on N estimators, and that's just from a little experience with this. So for subsample, we've already done this one, but we're putting it up for a reason. Number of rows, I usually go down by 0.2s for these, and then later we'll make adjustments, something like that. And then we can in effect do the same for the different call samples. Okay, so we had those up here. Call sample by tree. Okay, and then I'm just gonna copy this in. And then we're gonna do the same by node and by level. Okay, so copy it in here. Forgot to press return. And I can tell you, I've done very well with the call samples in the past. Okay, so what are some of the other parameters? Well, let's take a look. Okay, we've got let's go to the top here. We've got the learning rate. Okay, this is what I think it is in sklearn. And it says the default 0.3. It says shrinkage to produce overfitting. The learning rate is like how small of a step you're taking to kind of find the minimum. The range is 0 to 1 here. So for learning rate, let's try the following. Let's try 0.01. I think you definitely want to try. I think you could go smaller too. 0.005 perhaps is a good one. 0.01, so 0.1. Their default is 0.3. I think it's good to keep the defaults in there. Maybe 0.5 and then maybe something like, I don't know. It says 1 is the max. Maybe let's go 0.9. Okay. No, you don't want to be comprehensive. You just want to kind of like establish reasonable values within a range here. Okay, and we're going to keep going. So what else do we have? We have, we could try min child weight. And so, like, how do you figure out what to do with I skipped over gamma. We'll come back to that one. Let's go to min child weight. First thing, look at the range, 0 to infinity. The default is 1. It says minimum sum of instant weight needed in a child. That would be like a depth down. If the tree partition step results in a leaf node with a sum of instants less than min child weight, then the building process will stop partitioning. Okay. The larger, the more conservative. Okay. So when you get a sense of like what it does, okay, so min underscore child underscore weight. And it's said that the default is 1. Sending it up makes it more conservative. So you could just try some different numbers here. Okay, something like that. Okay, so we have this gamma, 0 to infinity. The default is 0, minimum loss reduction. The larger, the more conservative. And so let's try gamma. Okay, and default is 0 here. I'm not sure. With gamma, like maybe something like that. Okay. Might want to have more decimals in there, but something like that. Okay, and maybe we'll look at one more. Let's see what else we have here. Actually, this might be enough. Some of these are used for different, I can tell you, different processes. Okay, so you can't do a grid search on this, okay? You can't. Like, it's not going to work. It's way too much, right? Like, imagine that each of these had 5. It's like, that's close. 1, 2, 3, 4, somewhere more. Well, it's 5 to what? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So I'm just making an estimation here. So I've got 5 to the 8th. Okay, that's all combinations. But now I've also got times, well, an estimation is 100. The cross validation is 5, so it's times 500. So what is this? Like, how many decision trees would actually be built? Well, it would build 195 million decision trees. No, you don't want to do that. That's pushing the limits of the computation, I think, a little bit too much. So why did I bother doing this? Because you can try what's called a randomized search, and it will randomly set, like, I think it does like 10 by default, and will give you back the best combination. And that can be a cool way to start. So what we're going to do, we're going to modify this code. Okay? And I'm going to do the following. We're going to do from sklearn.modelSelection. It's a separate model, you could say. We're going to import RandomizedSearchCV. Okay? Now, what I like to do is the following. You can set random equal to false by default, and then but then if random, that means if it's true, what do? Let's just call it CLF perhaps. CLF now is the randomized search CV. That's the whole point. Nope, try that again. Randomized search CV, enter, check the parentheses. And then initer, okay, it's shown up there. Initer is 10 by default. If you have a small data set, why not search like 20 combinations? Okay, that's more to kind of check. And so otherwise, okay, this has to be either or, else the CLF is going to be the grid search. Okay, and then we can keep the rest as is. So let me just highlight what's happening here so that it's clear. Okay, this is a nice list of sort of parameters that you could start with, okay? There's no right or wrong to start with. But when you have a large list, you cannot check all combinations. We just showed it's going to build 193 million decision trees. It's simply too much. So what you can do is you can sort of check a random number of combination of these, and it's going to return the best combination. Right? That's what RandomizedSearchCV does not check them all. It has its own randomized sort of way. And I can tell you from my experience, that's often a good way to start. And you can sort of like change them and tweak them to kind of, you can narrow down the field, like sometimes can be helpful, but let's just do it once to start. Now in the code, okay, we have added this parameter random equals false. That's now a Boolean, it's a variable. So when you set it to true, okay, it's going to just do the randomized search CV. I realize you want everything else the same. You want the model, params, scoring. It's another, can be good to look at your code. The defaults are, well, let's just put an accuracy. Put the initer here, and CV equals 5. Okay. Hopefully that return worked okay. I'll just put it back just in case. You can still see it. Okay, so now let's try it. So this is just sort of storing the function. Now I haven't run these parameters yet. Okay, so I want to run those parameters. So now I've got the parameters stored. Now the latest model that's been stored we've always just done the XGB classifier as is. So now I should just be able to, I'm going to be down here. I should just be able to run this updated grid search model, but now I want to set random equal to true. Okay, so let's see what we get. We got an error. What did we do wrong here? It says it's missing required 2 positional arguments. Oh, yeah, sorry. I want to put in the default, right? It's not taking that for me. The params in the model, right? Yeah, params model. Okay, try it again. Okay, so it's only going to do 20 now. So, and you can Wait, that's not an updated, it didn't update the parameters. Sometimes this, in Colab, this can happen where like, let's try that again. Okay, and why do I know that? Because it's gonna show combinations of more of these. This is the params that we want, okay? And if you ever wanna be sure it's getting the new one, you can always try new params. So we press Shift Enter to new params. I try the new params here. Go ahead and run the code. Now it should do the 20 combinations. And okay, we're still getting that. Oh, it's because it's the grid CLF. Got it. I changed it to CLF. Okay. Now it's not going to do the one from before. Now it should do what we want. So we go ahead and run the code. We're waiting suspensefully to see, and you can see, look at that. We find a better score, and note it has a max depth of 5, but look at all these other parameters that are being compensated for it. This is the strength of XGBoost.